There are a couple logarithms with particular bases that are much more important than logarithms with other bases. So the logarithm with base 10 of x, this is called the common logarithm. And when we write log without any base at all, then it's assumed that the base is 10. So for example, if you wanted to do log of 100, then this means log base 10. And in order to find out what this is by hand, we would set it equal to y and write an exponential form. So since this is 10, then we get 100 is 10 to the y. And so this y here would be 2. And so log base 10 of 100 would be not 10, but 2. The other important logarithm is the logarithm with base e. So we define the natural logarithm, ln of x, this is called the natural log, as log base e of x. Remember here that e is the natural base. It is an irrational number that is approximately 2.71. And frequently when we have a natural logarithm, such as the natural logarithm of, say, 2, instead of saying the natural logarithm of 2, it's very common to hear ln of 2. With these definitions in place, let's do a couple of examples. So let's evaluate the following without a calculator. Log of 0.0001, ln of e to the 7th minus 2, and e to the ln of 1/2. So for log of 0.0001, I'm going to go ahead and set this equal to y and convert to exponential form. So we know that the base is 10 because there is no base, and the convention is that if there is no base, it's log base 10. So converting to exponential form, we get 0.0001 equals 10 to the y. Now in order to complete this problem, you'd have to make the observation that 10 to the minus 1 is 1/10, which is the same thing as 0.1. 10 to the minus 2 is 1/100th, which is the same thing as 0.01, and so on and so forth. 10 to the minus 3 would be 0.001, and so 10 to the minus 4 would be 0.0001. And so that means here that this y should be -4, because 10 to the minus 4 is 0.0001. And so in part A, this is equal to log of 0.0001 would be equal to -4. Let's take a look at part B. So we have ln of e to the 7th minus 2. Now because e is an irrational number, computing what e to the 7th is quite challenging. However, we can use the property that log base b of b to the x is x that we've discussed to conclude that ln, that is, remember, log base e, ln is log base e of e to the 7th. Since the bases match here, this is just going to be equal to 7. And so ln of e to the 7 will be 7, and so this is going to be equal to 7 minus 2, which is 5. Then finally in part C, recall that b to the log base b of x is x, as long as x is bigger than 0. Remember, x has to be in the domain of the logarithm here. And so what we have here is e to the ln of 1/2 is equal to 1/2. So we're able to evaluate this even though evaluating ln of 1/2 might be extremely challenging using the properties that we talked about previously.